All right, so as usual, if you ever have any questions while we're doing this, just make sure that you shout them out because I can't get everybody's picture on the screen, so I can't see if you're, um, putting the hand raise up or something like that. So I'm going to continue the Unit 1 notes. And later on in class, as you know, we're going to quiz over 1.1 and 1.3. So I'm just kind of backing up here. And, we left off talking about domain and range. And so we were talking about functions, domain and range. We did that, from a graphical point of view quite a bit. And we did some function notation. We did some piecewise graphs. And we even did a little bit of difference quotients. Not that you have to remember that term, but the algebra behind doing that. That was one of these big ugly problems that you guys seem to be doing all right with. All right, so today I want to go a little bit further on this idea of that function machine, okay? So, I drew that a while ago, and I'm gonna redraw another one down here. So I have to shrink this stuff up quite a bit. So I could fit in another picture for you guys. But we had, if we had a function box, let's say like this, and let's say that we had g of x. So g of x is equal to, and I'm just going to make up a function. How about 2x minus 1, okay? Just a nice, easy linear function. And let's say, the number 5 would be in the domain of that function, of course. So we're going to drop 5 into the function. So it's going to do 2 times 5, which is 10, and it's going to spit out a 9, okay? So we did this a while ago, and you guys seem to have a pretty good handle on it. But now, once it spits out that 9, I now am going to put another function right below it. And then 9 is going to drop into this function. So what happens is 9 then drops into the function f, which is going to square the number, and then ultimately it spits out an 81. Okay, so then again, to follow kind of the visual, we started with 5, we dropped 5 into G, it gave us an output of 9, but that output of 9 then became the input into F, so we dropped 9 into F, it squared it, and gave us a final output of 81. Okay, so this was our initial domain or our initial input, and this was our final range or final output. All right, you with me so far? All right, how about if you say yes or no? Could you give me a yes or no if you're with me so far?
Yes.
Now, how about I click on the number? I love you say it too, though. You're always welcome to speak up. All right, this is good. All right, well, what this is called is a composite function. And we would denote that this way. F of G of 5. And we say it F of G of 5. It sometimes is written this way also, F with an O, G of 5. Okay, that's called a composite function. What that means is, it's a bit counterintuitive. You do it from right to left now. And I know we read from left to right, but you do it from right to left. So this means I'm going to take 5 and plug it into G, and then take that answer and plug it into F. And that's exactly what we did. Okay, we took 5 and plugged it into G, and then took that answer and plugged it into F. Okay, this means the exact same thing. This is just more of an order of operations, like you do the parentheses first. So you do G of 5 first, and G of 5 came out to be this, because that means you plug 5 into G, and then you plug that into F. Okay, so all of these things are really showing the same idea called a composite function. So sticking with that, I'm going to look down here at these composite functions. Okay, so these are on your notes a little bit further down. Notice I skipped over that first section. I'll come back to that. So for a composite function, if we wanted to find, and again, you would say that j of k of -1. So if we want to find j of k of -1, we do this part first. So that means we're going to take -1, plug it into k. So when I plug -1 into k, I get -1 squared, which is 1, times 3, which is 3, and 3 to the third, which is 27. So that means this is 27. But now I have to take that 27 and plug it into j.
I'm confused.
Okay.
Can you do that again?
Yep. Maybe I'm going a little too quickly, so thank you for slowing me down. What we want to do in this case is the inside parentheses first. So kind of ignore this. And all we're finding is k of -1. So remember, that means that, you're going to plug -1 into k. Okay. And here is function k. So I'm going to plug -1 in for that x. So that means I'm going to do 3 times -1 squared, and then all to the third power. Well, when I do 3 times -1, I do the -1 squared, which is 1, times 3, which is 3. So that gives me 3 to the third, which is 27. Okay. So that means that k of -1 is 27. But now I have to plug that into j, because that was 27. So now I have to find j of 27. So you do the inside part first, and then whatever you get for that, that becomes then your input for the next function. So when we find then j of 27, that means I'm taking 27, plugging it into j. So I'll do, 3 minus 27, which is -24. But then the absolute value is positive 24. And so our final answer is positive 24. Okay, so I found k of -1 first. Then I took that answer and plugged it into j. Okay, I'm going to do this one next because it's most similar to it. So don't let this notation mess you up. That means the same as j of m of 49. So it's the exact same type of problem that we just did. We do the inside parentheses first. So we're going to find m of 49 first, and then plug our answer into j. So to find m of 49, I'm plugging 49 into m, so that's going to be negative square root of 49, which will be -7. So I did the inside part first and got -7, okay, because m of 49 is -7. I now have to take that -7 and plug it into j. So I do absolute value of 3 minus That's a -7 there. Sorry, my fat fingers can't get it. 3 minus -7, which will be then absolute value of 10, which is 10. Are we okay so far? Anybody have any questions? All right, then I'm going to roll a little bit more then. So this middle one is done the same way, but we just don't have a number that we're inputting. We're just putting x in. So if we take m of x, which actually is just this whole function, that means that we're taking that function and we're plugging it into k. So we're going to find k of that, because that is m of x. So I just replaced m of x with this because m of x is that. Now I have to take that guy, that negative square root of x, and plug it into k. So that means we're going to do, and I'll write this out because there's a little more algebra to it. We have 3, I'm plugging it in right here, guys. 3 times the opposite of the square root of x squared, and then we're going to cube it all. So I have to clean that up a little bit. So this negative times negative will be positive, and the square root of x times square root of x will just be x. So that's going to give me 3x cubed. And so then I have to cube the 3 and cube the x. So the final answer is 27x cubed. So again, that's a composite function. It's 2 steps. You do the inside function first. Okay, so you drop something into the inside function, get an output, but then you take that output, plug it into another function to get a final output. All right, I'm gonna move up top to the operations of functions. Because operations of functions work, I think it's a little more intuitive. It kind of works how maybe you would think it would work. If we wanted to find f plus g of x, that just means add the 2 functions together. So all we're doing is taking f of x, which is this, plus g of x, which is that. So it's just going to be the 2x squared plus 3x minus 4, that's f of x, and then plus g of x, which is 4x squared minus 10. We're just adding the 2 functions together. When we do that, so I'm going to combine my like terms, 2x squared and 4x squared is 6x squared, and plus 3x minus 14. I wrote it in descending order, of course. So you can add or subtract functions just using regular rules of algebra. Now that was a general function in terms of x. If you have a number, it actually is, I think, a little bit easier. If you have a number, you just do them individually. So if we're trying to find g minus f of 2, all we do is find g of 2 and find f of 2, and then just subtract those 2 numbers. Okay, so you kind of do them independently and then just subtract them. If it was addition, you'd do them independently and add them. If it was multiplication, you would do it independently and multiply them. So when I plug 2 into g, I get 2 squared is 4 times 4 is 16, minus 10, which is 6. Okay, so again, G of 2, I got 6 by plugging a 2 into there. F of 2, I have to plug my 2 into there for all the x's. So I have 2 squared, which is 4 times 2 is 8, plus 3 times 2 is 6 minus 4. So that comes out to be 10. So F of 2 is 10. And then I just subtract those two numbers. So I just did the
Where'd you get the 6 from?
From the 6 is G of 2. So I got that from plugging 2 into G. So I did 4 times 2 squared minus 10. Okay, that's G of 2. I plugged 2 into there. And 2 squared is 4, times 4 is 16, and minus 10 is 6. Okay, and thank you for asking questions, guys. Just shout them out if you have them, okay? All right, we got one more to do. Here we're going to multiply the two functions. So if that was a number, we would just find the f of that number and g of that number and multiply the numbers. But since it's x, that just means we're multiplying the two functions. So that means we're going to do 2x squared. Okay, I'm just rewriting f. 2x squared plus 3x minus 4. And then that's going to be times g of x, which is 4x squared minus 10. I got to do some ugly foiling here, but before I do that, let me know if I'm going too quickly. So I'm just going to multiply f times g in that case, okay?
Isn't it 2x squared?
It is 2x squared. Thank you. I missed my squared. Thank you very much. All right, so let's FOIL these guys, okay? So 2x squared times 4x squared, that's going to be 8x to the 4th. That times that is going to be minus 20x squared. And 3x times 4x squared is going to be plus 12x to the 3rd. And then 3x times negative 10 will be minus 30x. And then negative 4 times 4x squared is minus 16x squared. And negative 4 times negative 10 is positive 40. And we want to combine our like terms and write in descending order. So we have 8x to the 4th plus 12x to the 3rd. And we have minus 20x squared and minus 16x squared is going to give us negative 36x squared. And then we have minus 30x plus 40. And that big, long, ugly thing is our answer that we got from multiplying those two together. Okay, any questions on any of those operations or composites before we move on?